Okay, inverse trig functions, okay? First of all, if I am talking about something having an inverse, okay, it has to be 1 to 1. That means that both the vertical line test and the horizontal line test are passed by this function, okay? It must pass the horizontal line test, which is the reading a graph bottom to top, okay, with a horizontal line going up. Now, if for some reason it doesn't pass the horizontal line test, we can put restrictions on our function in order to make it work. As mathematicians, we don't like to be told what to do. We like to make up our own rules, okay? Y'all followed how mathematicians, we make up our own rules, right? Yeah, and some of you like them and some of you don't, okay? So, we're going to talk about these today. We're going to talk about sine, cosine, and tangent inverses. But let's talk notation. This is read sine inverse of x, okay? Just like we've done before with function notation, f inverse of x, sine inverse of x. Another way, and a synonym, is to say the arc sine of x, okay? So, arc sine and sine inverse, same thing. All right? Let's look down here at this graph, okay? I know that my domain for the sine function goes on forever, okay? This function is periodic. It's going to repeat. Well, if I try to see if it's going to pass the horizontal line test, right there I have a problem, right? Because I've got 1, 2, if I've got a horizontal line, I've got 1, 2, 3 points on it that I see, but it's actually going to be infinite. Yes? Because it goes on forever. So, I am going to pick some values of x. I'm going to go right here from pi over 2 to negative pi over 2 to positive pi over 2. This is the restricted graph. Okay? Negative pi over 2 to pi over 2. What I notice right here is that this passes the horizontal line test. There's only 1 point on that line at any given time. Okay? So, this right here is the graph of my inverse function. I had the ordered pair negative pi over 2, negative 1. But notice what I have now. This is negative 1, negative pi over 2. What did I do with my x and y coordinate? You swap them. Didn't we do that with our polynomial functions, or not polynomial, with our, well, yeah, really with any kind of functions we were working with. We swap the x and the y, and we solve for the new y. Okay? So, I had to put a domain restriction on here so that I could make these calculations. Okay? Let's take a look at page 59. And I want to highlight one thing. When I am making an inverse calculation, sine inverse, cosine inverse, tangent inverse, what I am solving for is the angle from the unit circle that makes that statement true. Pi over 6, pi over 4, anything like that, okay? So, the inverse functions are calculating angles. So here we go. Let's fill in this table for just my sine function, okay? Theta represents my angle measures, and then my sine represents the y values, or the y coordinate. Because I'm a visual person, okay, I'm going to come over here and I'm going to draw the part of the unit circle that domain covers, okay? I go from negative pi over 2, which is down here, to positive pi over 2. Does everybody understand why this is negative pi over 2? I'm going backwards pi over 2 radians, just like I would go forward, okay? So everything I'm working with right here falls in quadrants 1 and 4. Okay? All right, so here is negative pi over 2. The ordered pair here for negative pi over 2 is the ordered pair 0, negative 1. What's the y value? Negative 1. Okay? All right. Very quickly, this is pi over 6. This is pi over 4. This is pi over 3. We should know those. Okay? This one is negative pi over 6, negative pi over 4, and then negative pi over 3. Negative pi over 3 is the same thing as 5 pi over 3. Negative pi over 4 is the same thing as 7 pi over 4. But we're using the values that are in our restricted domain. Okay? So here we go. At negative pi over 3, my ordered pair is 1/2 negative root 3 over 2. For negative pi over 4, what is my y-coordinate? Thank you, baby. I'll get it in this afternoon.
Thank you.
You're welcome.
Negative 2 over, like that,
Negative root 2 over 2. Yeah. Okay, negative pi over 6 has a y-coordinate of negative 1/2. Y'all got to know your unit circle. Okay, this is positive root 3 over 2, negative 1/2. What about 0? 0 right here. What is my ordered pair? 1, 0. I want the y-coordinate, which is 0. Pi over 6 is right here. Pi over 6 has a coordinate of root 3 over 2, 1/2. Pi over 4 is root 2 over 2. Pi over 3 is root 3 over 2. And what about pi over 2? What is its y-coordinate? 1. Do you see how everything was just the opposite or represents a reflection over this x-axis with my values? Okay? All right, so we're going to use this table to help me figure out these exact values. Now, my brain does not work in inverse mode, okay? Sometimes I can't hardly get it to work in regular mode, okay? So what I'm going to do, remember, anytime I'm asking for an inverse, I'm asking you to tell me what angle gives me that output. So I'm going to rearrange my equation. I'm going to set this equal to theta. Theta represents my angles. Trying to find the angle. Okay, we have multiplication and division. We have addition and subtraction. We have squaring, square rooting. Those are all what of each other? Inverse operations, okay? What would I need to get rid of the sign inverse? Nope. It's almost like thinking, how would I get rid of the sign inverse? Okay, I can understand how you would see that with that being like in the exponent position, okay? But what I'm actually going to do is I'm going to take the sine of both sides. The sine and the sine inverse cancel each other out, okay? So what I've got left here is 1 equals sine of theta. I don't read right to left, so I'm going to flip this. I'm going to say the sine of theta is equal to 1. And I literally want to know, this is how I understand it. I want to know what angle gives me a y value of 1. All I need to do is go right here and look at my table and find the output or the sine of 1. Thanks, dear. Okay? And my angle is what? What is paired up with the 1, y'all? Look at the table. Pi over 2. Okay? Pi over 2 is my answer. Okay? Next, I'm going to set this one equal to theta. My job is to calculate the angle that makes this true. Okay? To get rid of the sine inverse, I'm going to take the sine of both sides. Pay attention. Sine and sine inverse cancel each other out. I'm going to go ahead and rewrite this with the sine on the left side. I'm going to say sine of theta equals -1/2. So I'm looking through my table for a y value of -1/2. Oh, and look at that. That happened at -pi/6. Okay? Let's do the same thing right here for C. Okay? I'm going to take the sine of both sides. Do unto one side as you do unto the other. That's the golden rule of algebra. Okay? And I'm going to say that sine of theta is equal to the square root of 2 over 2. What angle makes that a true statement? Pi over 4. Excellent. Okay. Sorry, you can't see. All right, same thing for the last one, y'all. Okay, I'm going to take the sine of both sides. The sine and sine inverse cancel out. Okay, and I've got sine of theta equals 3 over 2. Do you see anywhere in this table up here where it says 3 over 2? No. All right, real quick. 3 over 2 is equivalent to 1.5. What is the radius of the unit circle? 1. The radius has a length of 1. This right here, that's a problem. We cannot do this when it's greater than 1, okay? So I'm going to put a slash through that equal sign, and I'm going to say not equal to, because it was set equal to something that was bigger than 1 there. Okay? Questions?
So you wouldn't go all the way around and just do one whole thing and go to like 90?
All right, flip it over and let's look at the cosine. Okay, we're going to do the same thing with the cosine. We have to restrict the domain of this function. We are making these rules because we want to be able to do something with it, okay? It does not pass the horizontal line test. So I'm going to start at 0 and I'm going to stop at pi. Because if you notice, this right here, just between these two boundaries, it does not violate the horizontal line test, okay? So this is the restricted domain, and then this is the graph of the inverse, okay? Right here, I have the ordered pair of pi, -1 on my graph, but here I have -1 pi, and so forth. All you're doing is taking your x and your y's, and you are flip-flopping them. Okay? So, I restricted my domain right here from 0 to pi. So that's what I'm working with in my table. Now, 0 to pi That goes from right here to right here. So that is quadrant 1 and 2. And I'm thinking ordered pairs, okay? If I know my unit circle, this should not be a difficult thing to do. Theta is my angle measure, and cosine here, those are my x values. So I'm thinking about my coordinates, and I'm writing down the x value, okay? 0, that's over here. 0 what? My angle is 0, so my order pair is 1, 0. The x value is 1. Okay? Then pi over 6. That's root 3 over 2, 1/2. So the x coordinate was root 3 over 2. And you got pi over 4. All of my 4s are root 2s over 2s. You just got to know your sign. And then pi over 3, that's 1/2. What about pi over 2? 0, that's my x coordinate, right? 0, 1. 2 pi over 3. Okay, that's right here. That's negative 1/2. Do y'all see how these are going to be a reflection? So the thing that's going to change is the sign. So this is going to be negative root 2 over 2, negative root 3 over 2, and then negative 1. Okay? All 4 of these down here ask me to find an angle measure for that x value, okay? I am going to set each one of these equal to theta because I want to solve for the angle that makes that a true statement. How am I going to get rid of a cosine inverse? Cosine. So if I take the cosine of both sides, cosine and cosine inverse will cancel, and I've got cosine of theta equals 0. Looking through here, looking for that x value of 0, that happens when the angle is pi over 2. Okay? For this one, take the cosine of both sides. Cosine, cosine inverse, cancel each other out. And I'm left with cosine theta equals 2. Do I have anything in my table that shows a 2? No. I'm going to say not equal, and my reason is because this x value is greater than 1. I want you to try C and D real quick. Okay, C and D, you do that. Show your work. You're looking at your table and finding the x value that's paired up with that. Please don't run your mouth. You need to be working. You can have social time at 3 o'clock. Hey, you're good. You're welcome, hon. Okay, I've got mine done. Just waiting on you guys. We'll check it. Remember, you're looking for theta, the angle value that makes that true. Okay? I got pi over 4 and 2 pi over 3. Are y'all good? Yes. Anybody get mixed up anywhere? Here I was just looking up here for the root 2 over 2, and that was pi over 4. Here I was looking for a negative 1/2, and that's 2 pi over 3. Okay? All right, let's do the same thing for tangent. Okay? My tangent function Okay, there's not much that sine, cosine, and tangent have in common, but they do have in common that they don't pass the horizontal line test. So once again, I'm going to restrict my domain, and I'm going to restrict it to my starting, stopping asymptotes, because between those asymptotes, it passes the horizontal line test, okay? So this is the graph of the inverse, okay? What do you notice about your domain of this inverse function? It flips sideways, so what is it? What's your domain? Domain is our x values, right? All real numbers. You can write negative infinity to positive infinity or a fancy little r. What about our range here? Okay, and what am I going to put around those negative and positive pi over 2's?
Parentheses, but they're not included.
Correct. Parentheses because they're not included. Excellent. Okay, so right here, because I'm restricted, okay, I am restricted to negative pi over 2 to positive pi over 2. Well, negative pi over 2, once again, is down here on the bottom part of the y-axis, and positive pi over 2 is up here. So all of my answers are going to come from the coordinates that are here. Okay? All right. Theta represents my angle measure. How do I find the tangent? Y over x. So there is a calculation involved. Okay? So real quick, okay, I need my coordinates because I have to divide the y coordinate by the x coordinate. Okay? So what I'm going to do, okay, I'm going to go through and I'm going to write the coordinates that I know real quick. So negative pi over 2 is the coordinate 0, negative 1. I'm going to write this right above this. I know that my 0 degree angle has an ordered pair of 1, 0, and that pi over 2 has a coordinate of 0, 1. Okay? Now I also know that pi over 6 is right here. Pi over 6 has an ordered pair of root 3 over 2, 1/2. So negative pi over 6 is going to have the coordinate root 3 over 2, negative 1/2. Positive pi over 4 is root 2 over 2, root 2 over 2. And negative pi over 4, positive root 2 over 2, negative root 2 over 2. Whoa, what did I do? I put it in the wrong spot. Okay, so this one right here, I'll get to that in a second, I'll fix that. Okay, right here, pi over 3 is up here. I've got a coordinate of 1/2 root 3 over 2. And this one is 1/2 negative root 3 over 2. This is negative 1/2, y'all. I'm so sorry. If I had a whiteout pen, I'd use it. Okay. All right. I'm going to perform the calculations. I'm going to take my y coordinate and divide it by my x coordinate. So right here, for negative pi over 2, I'm doing negative 1 divided by 0. What is that? Okay? All right, so just a reminder, this right here is a no-no. This is a no-no, and this is okay. All right? So right here, instead of saying undefined, I'm going to write DNE for does not exist. Same thing as undefined, okay? All right. Then I get to this one. My y-coordinate is the negative square root 3 over 2, and I divide it by the x-coordinate, okay? I'm going to divide it by the x-coordinate, which is positive 1/2. Now, when I divide fractions, you multiply by the reciprocal. So I'm going to multiply by 2 over 1. The 2's cancel, and that leaves me with negative root 3 over 1, so that's just negative square root 3. Okay? Right here, for this one, I've got negative root 2 over 2, and then I'm going to multiply by the reciprocal of the x-coordinate. Those cancel, but I've got a negative left. If everything cancels out, do I leave a blank? What is anything divided by itself? 1. So this is negative 1. Good job. Okay? And then this negative pi over 6, my y-coordinate was negative 1/2, and I'm going to multiply it by the reciprocal of the x-coordinate, which is 2 over root 3. The 2's cancel out. I'm left with negative 1 over square root 3. You would have to rationalize that. So this is negative square root 3 over 3. Okay? All right. Next, I've got 0 divided by 1. Zero. Okay? Then right here, my y-coordinate is positive 1/2, and I'm going to multiply by the reciprocal, which is going to be 2 over square root 3. I end up getting the same thing I had here, with the exception of now it's positive. So this is positive root 3 over 3. This is going to be a reflection, okay, with sign changes. So this becomes positive 1, okay? And then right here, this is going to be positive root 3. And then right here, if I do 1 over 0, does not exist. Okay? Do you recognize the negative 1, 0, 1 as our key points? Okay? Y'all sit up, please. Okay. I want for you guys to calculate these for me. If I set every single one of these equal to theta, okay, what do I need to take of both sides to get rid of the tangent inverse? The tangent, okay? So the first one, just to kind of show you how I would set it up, I'm going to take the tangent of both sides. Tangent and tangent inverse cancel out, okay? I want you to do those, and I want you to check your work with your neighbor. And when we do this in class, okay, if you do not show your work, you do not get credit. Did whoever do this rationalize very well? Yes, no? They did not rationalize, but it's still equivalent, okay? You good? Check and see if you got what I got. If I did something wrong, let me know. Promise you're not going to hurt my feelings. Are we good?
How did you do?
Okay, so 1 over square root 3 is the same thing as square root 3 over 3. This just has not been rationalized yet. So here, if I multiply both the numerator and denominator by square root 3, that gets rid of the radical and gives me 1 on top. Okay, so this is equivalent to the root 3 over 3. Good question. Okay? All right, let's keep going. Grab your calculator, okay? Our calculator is a handy tool. However, our calculator must be in radian mode, okay? So how do we check the mode on our calculator? You literally hit mode. That's so difficult, isn't it? Okay? All right, now, this is already in radian mode, so I'm going to get out of this, second quit, okay? On the calculator, we have sine, cosine, and tangent. And right above that, in the blue letters, is sine inverse, cosine inverse, tangent inverse. To get those, you just hit second. So I am literally going to type in sine inverse, second sine. You can type the little alpha y equals and do the fraction. You can do 1 divided by 4. Shoot, you could even put in 0.25. It's all equivalent, okay? And I'm asked to round to 3 decimal places. What does this give me to 3 decimal places?
0.253.
Perfect. Okay? All right, I'm going to do the same for the others. Second cosine, negative 3 divided by 5. I'm going to say that this one is approximately 2.214. And we got tangent, second tangent, and you got 4.5. I'm actually, let's see, this is 1.352. Then I'm going to go back to cosine, cosine inverse of 1.5. Oof, what happened? An error. You cannot plug anything in to the inverse function right here that doesn't fit into the domain, okay? Right here, x is greater than 1. So this one right here, we're going to write is not possible. Okay, down at the bottom it says, if a function is 1-to-1 and passes the horizontal line test, then its inverse relation is also a function. For sine, cosine, and tangent, we have restricted the domains for each function to discover these properties. Remember our inverse lessons from our previous unit. When we did composition of functions, when I plugged one function into the other and they were inverses, the only thing that I was left with in the very end was x, okay? So we're going to apply this same idea to sine, cosine, and tangent and their inverse functions, okay? So down here, we are given a list of properties, and we are given a list of domain restrictions, okay? You do not have to memorize this. I will give this to you, okay? So I will give you this on a quiz, on a test, practice, anything, okay? You do not have to memorize it, but we are going to refer back to it. Notice we've got sine of sine inverse of sine, same thing with the cosines and same thing with the tangents. Notice that it doesn't do anything like using one function and another function. Okay? Here we go, flip it over. Okay. We're going to use the restrictions that we need. Okay? We are doing the sine inverse of a sine. Sine inverse of a sine is limited to negative pi over 2 to pi over 2. That means that whatever my final answer is has to fall within that range, okay? Now, negative pi over 2, positive pi over 2. My answer, or answers, have to fall somewhere in here. Okay? The very first thing that I'm going to do, I'm going to calculate the innermost part of my function. That's step 1. Okay? So I'm going to take sine of 2 pi over 3. And this is asking me to calculate the y value. Well, 2 pi over 3 is right here in the third quadrant. What's the ordered pair for 2 pi over 3? It's the first one past the y-axis. What side of the origin is this on? It's on the left side, right? So that means you have a negative x-coordinate, and up here, above the x-axis, you have a positive y-coordinate. What is the coordinate? Negative 1/2 and square root 3 over 2. Perfect. Okay? So what I need is the y value. The y value is this square root 3 over 2. Okay? So I solved for this right here. So my next step, I'm going to do sine inverse of square root 3 over 2. Okay? Literally, I solved the innermost part, and then I plugged it in. Thank you, hon. I'll get it updated in just a little bit. Okay? So I'm solving for an angle. Remember, anytime you're doing an inverse, you're solving for an angle. So I'm going to set that equal to theta. And I am going to take the sine of both sides. Okay? So I'm going to say that the sine of theta is equal to the square root of 3 over 2. Any answer that I give has to fall in this area. Okay? Is there an angle that gives me a y-coordinate of root 3 over 2 in here? Gabriel, sit up. Come on, y'all. I've literally got 9 people in here. Somebody's got to talk to me. Is there any angle on this unit circle that falls in quadrant 1 or 4 that gives me a y value of positive root 3 over 2?
Fourth quadrant.
Huh?
Fourth quadrant.
Nope. Fourth quadrant has a negative y value. I want a positive y value. That's going to be up here at pi over 3. This has the ordered pair, 1/2 root 3 over 2. Y'all have got to know your unit circle. If you do not know your unit circle, you are going to die. Okay? All right. Now, looking at this one, my innermost function is asking me to use an angle. Now, I know that 3 pi over 4, okay, 3 pi over 4 might cause me some problems. I'm taking the cosine of cosine inverse, so I'm going to flip over here, cosine of cosine inverse. It has to fall between -1 and +1. But I'm going to check this, because 3 pi over 4, I want to know the value of that real quick. So I'm going to do alpha y equals 3 pi over 4, and that gives me a value of 2.356. Okay, keep that in mind. Okay, because I'm going to type the innermost part. I'm going to do second cosine of second entry. Oh man, hold on. Second cosine, I'm just going to do it again. Alpha y equals 3 pi over 4. What did it give me? Gave me that domain error. Why? This number right here falls outside of the boundary. Okay? So right here, I'm going to say, get the same wording I had. The expression is not defined. Because 3 pi over 4 lies outside the boundaries -1 to 1. So this one, there is no answer, okay?
Really need to remember that, the part there, for the,
You talking about all the intervals?
yes.
No, I'm giving those to you. Okay? All right, here we go. Cosine inverse of cosine. Let's flip over here. Cosine inverse of cosine, I'm going from 0 to pi. Okay? From 0 to pi. 0 to pi is from here to here. So my answers, my final answers for this problem, if I have any, they're going to have to land here in that boundary. Okay? So I am going to start with my innermost function, and right here, I'm going to calculate.
Excuse this interruption, teachers. I need all students who are riding the bus. When the bell rings, they need to go to the bus ramp. Do not go to the cafeteria. All bus riders will go directly to the bus ramp today. And all students remember that we're wearing purple tomorrow, purple up for Military Month.
Okay, 7 pi over 6 is the first one past the x-axis, okay? The cosine of that ordered pair, my ordered pair is -√3 over 2, -1/2 right here. So the cosine is -√3 over 2, and that is what I'm going to substitute. So here I'm going to do cosine inverse of -√3 over 2. Anytime I'm asked to calculate an inverse, I am solving for an angle. So I'm going to take the cosine of both sides. So I've got the cosine of theta equals -√3 over 2. Now think about your unit circle. Is there anywhere in this shaded region in my boundary restrictions that I have an x-coordinate of -√3 over 2?
5 pi over 6.
5 pi over 6. Excellent. Okay? So theta equals 5 pi over 6. Okay? All right. Do you see how I'm taking the cosine of a sine inverse? Yes? Okay? There's no domain restrictions here. So I'm going to start with the innermost function. Okay? So I'm going to do sine inverse of negative 1/2, and I'm going to set this equal to theta. Okay? I'm going to take the sine of both sides. So I have sine of theta equals negative 1/2. Now for the sine function, okay, for the sine, it falls over here. Okay? So what angle do I have that I have a y-coordinate right here of negative 1/2? What's that one? It's 11 pi over 6, but what is it within this domain? It's negative pi over 6. Okay? So this is what I'm going to substitute back in to my original function. And I'm going to evaluate the cosine of negative pi over 6. Well, negative pi over 6 is the first one down here, and that has the ordered pair, square root 3 over 2, negative 1/2. So right here, this comes out to equal positive root 3 over 2. Notice I didn't say that theta was equal to that, because here I wasn't solving for an angle. Okay? All right, very quickly, I need to get through 2 more problems, okay, in 2 minutes. It says, find the exact value of the sine of cosine inverse of 5 over 13. I'm going to start with the innermost function, okay? You've got cosine inverse of 5/13, and I'm going to set this equal to theta, okay? If I take the cosine of both sides, I can rewrite this as the cosine of theta is 5 over 13. Well, this is just a ratio for me. That's my x value and my radius. So I'm going to come draw a right triangle where I have an x coordinate of 5 and a hypotenuse of 13. Okay? I'm going to put theta in there. If I can, all I needed this for was to set up my triangle, okay? I eventually just want to write the sine of theta. That's all I'm looking for. But in order to write the sine, which is y over r, I need my y value. So I've got Pythagorean theorem to help me out. Okay? We'll pick up there tomorrow. Y'all have a great day.